Well, hey everyone, welcome. Thanks for joining the broadcast today. This is a new series we're starting called Voice and Robotics. So if you followed our Amazon Alexa channel for a while, you'll know that we do a lot of different things on here. We do office hours for help with your Alexa skills kit issues. We introduce new features, new products to you. This is going to be something different, and it's kind of spun off of the excitement and the interest we saw at Remars. So if you were able to come to Remars this past June, then you hopefully got to see the BattleBots competition. So what I want to do today is some live coding. I want to show you what we're going to do over the next few weeks. We're going to be using the Alexa Skills Kit. We're going to use AWS IoT. In fact, most Fridays throughout the rest of 2019, you can join here at the same time, 11 Pacific, 1 Central, 2 Eastern, and you can watch us do this. So from time to time, I'll have on special guests. So we'll have people like roboticists from different universities. We'll have Amazon roboticists that use Amazon robots inside of our warehouses. So we'll have them talk to you about how they work and what they do. We'll also just do a lot of deep dive on live coding. So I'm excited. Thanks for joining us on that. My name's Jeff Nunn. My Twitch handle is JB Nunn. So if you follow me at twitch.tv/JB Nunn, you can also see what I do behind the scenes. So a lot of the work I do here, I try to do it pretty smoothly where you don't have to sit through a lot of my mistakes. But if you want to see how a real developer works, we use Google a lot. We use Stack Overflow, and we make a lot of mistakes. So join me on my Twitch channel throughout the week. You can follow me there. Be sure to follow us at Amazon Alexa too, and then come in on Fridays. Okay, so what can you expect over the next few weeks? Well, first of all, if you have questions during this, please post them to the chat. I'll keep an eye on the chat window over here, but I'd love to know what questions you have. Let's talk about what a robot is, first of all. So a robot, typically you think of the ones maybe from the Jetsons or these classic robots that have arms and legs and a big boxy head. That's not all a robot is. You can also get a robot out of anything that can sense the environment or interact with you or the environment. So you probably have a robot in your house right now that you're not even thinking about, which would be something like a smart thermostat. So you have a Nest thermostat maybe. That can sense the environment, and then once it senses it, it can make decisions on whether to turn it up or down. You can interact with it from your mobile device. You can code against APIs for things like that. Smart locks, smart bulbs. Really, a smart bulb may not be able to sense the environment necessarily, but it can sense other bulbs around it or other actions, and so it can take action. So you can make an argument that even that's a robot. So through this, we will play around with a lot of robots. Let me show you one I have now. So this is the Create. So the Create robot, if you have a Roomba at home, then you basically have the Create. The Create is just a robot that is a platform actually from iRobot that gives you all the functionality of a Roomba, except for the sweeping function. But it gives you all the sensors. So I've got a left sensor and a right sensor. I've got some proximity sensors. I've got bumpers. I've got wheels underneath. What the Create does, though, it gives you a serial port. So you can interact with the robot by using a Raspberry Pi or other device, maybe like an Arduino, and you can interact with the robot through Python or Node. So today we'll use some Python. We'll code this. We'll make it move around. We may have some fun and add a little spinner to it, make it spin around. But I think you'll enjoy the Create. So take a look at that if you get a chance. Let me see here if we have any questions yet. All right, so far so good. So that's a Create, that's what we'll play with today. So make sure to stick around for that. I'll dive into code a little bit later. And then what you can expect over the next few weeks is we'll talk about the different ways to connect your voice to robots. So let me switch now to this. Let me show you, there's 3 different ways. So if we think about a robot, our main thing is we have a person, right? We have a person that wants to talk to a robot. So they're going to go, sorry, there's a big motor outside of our window. They want to go somehow to a robot. So let's draw the Roomba over here. A nice little Roomba. It's got wheels on it. It's got some sensors that can sense things. It's got bumpers that can feel things. And then we're going to talk to an Echo device usually. So we've got an Echo. We're going to use the Alexa Skills Kit to work with our voice and our intents and send commands. But where do we send those commands? So that's the problem I want to solve for you today and over the next few weeks. Hopefully by the end of the day, you're going to at least know how to start doing this. So there are several different ways to do it. So let's outline those ways. The first way would be through messages, and we call those messages pub sub. It's a pub sub model. So there's publishers and subscribers. So that's the first method. The second way to interact and to use your voice of the robot would be with Bluetooth. So we can set up an Echo device to remotely pair with a robot, and then just send our commands to the Echo. The Echo will then use Bluetooth to send those commands to the robot. And then the third way would just be a direct interaction. So imagine you have a robot and you're able to just build right on top of the robot, maybe with a Raspberry Pi, maybe with a little Wi-Fi dongle. You'd need a microphone here, so maybe there'd be another dongle for a microphone, but you're able to directly interact with the robot through that. And if you're confused on when you would use each of those, hopefully this table will help you out. So here are the three methods, and again, we'll cover these over the next 3 to 6 weeks. The first one is PubSub. You're going to see that one in action today. I'll dive into PubSub and you'll see how that works. So this is good for when the device has an internet connection. There are no distance limitations, meaning you can control a robot right next to you, like I have today with the little robot next to us, or you can control a robot from across the world. Examples of this would be thermostats, door locks, light bulbs, coffee pots, things like that. The cleaner, maybe even some mowers. Another advantage of PubSub is you can update code to hundreds of thousands of devices, millions of devices at the same time. You can send commands to all those at the same time. So today we'll talk about PubSub. Next week we'll start into Bluetooth. So these are devices that can communicate with from your Echo to a device over Bluetooth. And the good thing about this is you don't need to have speakers on the robot. You don't need to have any audio processing. That becomes really expensive as far as processing power and time that's required. And you'll see a lot of examples of this in the next couple of weeks with gadgets, games, smart toys. We have a team, the Alexa Gadgets team, that will join us and show us how they're using it now. We just announced some new features that they'll talk about. So I hope you'll come in at least for the next couple of weeks to see that if you're interested in the Bluetooth. And finally, the last thing is direct connection. So this is direct communication with a robot via microphones or a microphone on the robot. So you can imagine a robot with a microphone array that's listening, and it's picking up your voice and then doing something. So that basically gives you the functionality of an Echo device built into any robot. And you can see examples of this already. You may have it. So your smart TV might work with Alexa already. Probably does if you have a recent one. If you have the Bose Quiet Comfort headphones, for example, there's a button there that you can click to activate activate interaction with Alexa. So you'll see a lot of that. And then we'll bring that team in. That's the Alexa voice service team. I'll bring them in a few weeks from now as well, and you can see if that's something for you. So we hope we've given you 3 good ways to do it. And again, today, this will just be about PubSub. So if you have questions about that, let me know. All right, so with that, I think we should probably dive in. Let me show you a quick example first before we dive too far in. So let's go back to Robot Cam. And I'll unmute my Alexa. Okay. Alexa, open Twitch Robot.
Hi, I'm your friendly robot. You can give me commands like move forward, move backwards, or spin around.
Move forwards.
Okay, moving forward.
All right, so you can stop. So you can see it's pretty quick.
I'll stop the robot.
Thanks, Alexa. All right, pretty quick. I just wanted to show you a quick demo of how it moves. So basically what's happening is I'm communicating through PubSub to the internet. I send a signal, which Alexa Skills sends a signal, a message to a broker. Let's go back to this. I'll show you how it works. All right, this is PubSub. Okay, so we have a broker. Let's just indicate this broker with this solid blue dot. And then we'll have a robot. In this case, let's make it a friendly little boxy robot. And then we have our happy user over here. Our user has an Echo. We're speaking to the Echo. So the Echo sends a message to the broker. This is called a publication, a pub. And our broker sits up here and listens, and it is continually sending out messages to our robots. So our robot says, oh wow, I got a message to move forward. I'm going to move forward. Then it goes forward. So that's PubSub in a nutshell. And I'll show you how that works with AWS. All right, let's go here. So I'm already logged into AWS IoT. So IoT is a service that you'll want to use. So when you first come in here and set this up, let me start from scratch here. Let's go to IoT. Okay, we can onboard a device. So if you're going to do it this way, come into IoT, you're going to configure a device. You're going to pick your platform and your SDK. And then you can give your device a name. So in this case, I called it a create. You can call it the Roomba. You can call it whatever you want. We'll hit next step. And then it generates these keys. Now this is the important part right here. So it generates keys for us. It'll let us download this key if I continued. But this is what lets us communicate securely with the device. So we could have these keys on our device, and we do, and that lets us securely communicate to AWS IoT without having to store passwords or credentials on the device itself in plain text. So let me show you what that looks like. We'll go here to our Ubuntu shell. So what I've done is I've SSH'd into the Raspberry Pi. So we're on the Raspberry Pi right now. So if I go back to the home, you can see I have some keys here. So I've got an iRobot Raspberry Pi cert, I've got a private key, I've got a public key, and I've got this root cert. These 4 things are essential for communication for PubSub, and they all come from AWS IoT. So you will need to go to AWS IoT, create a device, and then it'll let you download these certificates. And then you place those certificates on your Raspberry Pi. If you have any questions, let me know. Let's see. Any chance echo input is more useful in this context? Echo input. So echo input would be another way to do it. What I'll do now is take some notes on questions that we have. So let me take some notes here. And if we don't get those answered for you, then we'll answer those for you after the show. So I'm going to write down echo input, and that's startup Sanatana. All right, great. Thanks for the question. Okay, so here are the devices. This lets us communicate securely. And then what we have is this create package. You just heard it disconnect. So this create package was released by iRobot, and they give you the SDK that will let you work with that robot. If you get that, let me show you where you need to go to get the software to connect everything. So go to GitHub, and actually go to my account. So go to GitHub JB Nunn, go to repositories, and then look for Create Autonomy. I forked this off the original Create Autonomy, and I just made a few changes to make it work and to modernize it a little bit. So this works for the Create 2. The original one worked for the Create 1. I made a few changes to make that work. It has all the software you need, so you'll just need to clone this to your Raspberry Pi and then follow these steps. So there's some basic steps here. You'll install some dependencies. Once you've got all that installed, then we need to launch the driver. So this driver is a listener that sits on the robot and it listens for commands. It's basically saying, okay, I'm ready to subscribe to topics, to get information, to get data from you. So let's run that right now on the create. Let's just copy this here. ROS launch CA driver create 2.launch. So you'll need to run this in one window. What's happening behind the scenes here is it's running software called ROS, Robotic Operating System. What did I do? I misspelled this. And ROS listens, it sets up listeners. It engages all of the things like servos. Let me show you what all is on this create. You can have access to all of these. So we've got access to the battery, we've got access to buttons, we've got access to the command velocity topic, which is what it uses to spin and to move. We've got access to the bumpers. The wheel drop, does that mean one of the wheels have dropped maybe off a step or something? It's got IR signals, so it can kind of sense and look for IR signals. Those IR signals are important to stop it from going to certain rooms, for example. So we have access now through this package to all of these topics. A topic, by the way, is what PubSub uses to communicate with each other. All right, so let's go back. That little beep you heard while I was talking was the create saying it's ready. So we can see it's ready, it's listening. Now what we need to do is, let's go to my other window. And in this, I have let's go to Create Workspace. Let's go to the source directory. Let's go to Alexa. And I have a file here called listener.py, and I'll show you what that looks like. Okay, so listener.py, first of all, it gives an AWS IoT endpoint. This is the endpoint of the broker it's listening to get messages. So here's our endpoint. This will be different for you than it is for me. So when you create your account and create your IoT service, you'll get an endpoint like this. Then we give it the credentials. So those credentials I mentioned earlier, here they are here. We're just specifying them here. Yours will be different. You might have the same name, but they will be different contents of the files. Okay. And this is, I know it's a lot of code to look at. If you're taking screenshots, that's fine, but I'll post all of this on GitHub after the broadcast, so that way you can have it all and just copy and paste it if you'd like. So this command velocity topic, this is a topic that a lot of robots that use the robotic operating system, ROS, use to move around. So this is a really common topic to look for whenever you're trying to make a robot move. And all we want to do is take our voice or take our input from Alexa Skills Kit and send a message to that topic. So I've got one function here called forward. And what it does is listens and it moves the robot on 6 different parameters. So the parameters are X, Y, and Z for linear and X, Y, and Z for angular. The way to think about that is X on linear, X is moving forward, so anything positive will move it forward, negative would move it backwards. You can see here I'm moving it 0.5. Y moves right and left, and then Z moves up and down. So since we have a Roomba basically, we're not going to be able to move it and fly it up and down, so Z will always be 0. Now the angular part is the twist, it's the spin. So X, if you remember our X axis was going this way, the twist on the X would be twisting like this. Well, the Roomba doesn't do that. It doesn't have jacks or pumps that would make it move like this. The Y, it would twist around this axis. We can definitely do that. And then the Z, I'm sorry, this is the Z. The Y would be the horizontal, and we're not going to twist horizontal. The Z is the vertical one we want. And we can twist around that. So whenever we make a spin move, for example, we will adjust the Z. Hopefully that makes sense. Let me see if I've confused anyone. All right, so far so good. And Ice Cream Codes has a good plan there, so we need to watch his stream as well. All right, I've got one more function here called stop, and that just sets everything to 0 so that the robot will stop. There's a few other little utility things here to handle control C's when I break out. But here's the important part here. So I am listening. Let's go right here. At the near the very end, I'm subscribing to a topic. So I'm doing the sub part of pub sub. I'm subscribing to voice/drive. So any message I send to voice/drive will get delivered to this Roomba. And let me just show you. Let's get out of this and run this first. Takes a few to get set up. Put the Git link in the chat. Sure, let me do that. I'm going to go back to it while we're... Let's see how I can get to the chat. I think I can do it right here. 1 second, I'm putting that link there for you. Create autonomy. There you go. Okay, so now we're listening on voice drive. So let's go back to our AWS IoT service. And it has a nice little tool here called test. So go to test. Go to publish a topic. Let me make this a little larger. There we go. How's that? All right. And here we go. Publish a topic and a message. Okay. So we're going to point to voice drive. That was a topic. I'm going to change this to data because that's what my Python code is listening for. And I'm going to say forward. Before I hit publish, I'm going to switch over to Robot Cam and make sure that you can see it go forward. Okay, so on my screen now, I'm pushing publish to topic. There it goes. Cool. So we know that we're getting a message there. Let me show you back in our Ubuntu shell that it was listening, and then it received some data, and then it got a command to move forward. And let me show you that part of the code one more time so you can see it. So here's forward. So when it gets a message, it calls a callback. So let me show you where I have subscribed to this callback. Right here. Subscribe, we're listening on voice drive, and when we get data, we go to drive callback. Drive callback is right here. I've just print some debug messages. Once I see that the command was forward, then we move forward, and that's it. So what I want to do now is add a new command. So we're going to add a new command called spin. We're going to look for the spin command. Let's do that together. And I think we can, let's do def spin. For now, let's go here. Let's go do some copying and pasting. So we're going to type in command velocity. spin. Let's just see if this works. Okay, can you see this font? Let me blow this up a little bit too. So the code for spin, let's find that. So they call it rotate, and let's see if they're doing, so we've got Angular Z, which is perfect. We'll copy most of this code. So let's bring this over here. Okay, so here's spin. So let's init a new node. So we're gonna do ROSPy. Actually, I think we're okay with that. We don't need to do that. Yeah, we can just do a new message. So we're going to create a new message called twist. Twist is a built-in ROS message, and it comes with the 6 parameters that I mentioned, the X, Y, Z for both linear and angular. So if you want to see more about twist, you can always go and look at ROS messages, twist, and it'll give you the full parameters for it. That's not a great one. Sometimes when you're searching for ROS, it helps, especially if you're doing it in Python, to put Python at the end because they have C code. Yeah, there's some good twist examples, but we have the one we want right now. Okay, so we're going to start a new message, an empty twist message. Let's modify it now. So this particular code uses some input. We're not going to worry about input, but we'll set these variables ourselves. So we'll call speed, so degrees per second. So let's say we're going to have to make the robot do a 360, so we'll do 60 degrees per second. It should take 6 seconds to turn around. Angle is going to be 360, and we're just going to go clockwise. That's fine. So let's set the angular speed here. So pi equals 3.14159. I don't think we need much more than that. All right, angular speed is speed times 2 times pi over 360. This is just converting to radians. This is angle times 2 times pi over 360. Okay, and so now we know, since we're going to spin, we don't need any linear at all, right? So vel message linear.x is going to be 0, and we're going to do the same thing for y and z. Oops, let's cancel that. All right, so linear will stay the same. We just want to twist on the z. Let's do it for angular x and y. All right, cool. So we know we're already going to go one direction. That's fine. Let's do this time. So what it's going to do is spin until it reaches that amount of radians that we specified. So ROSPy, we're setting T0 because ROSPy time now to seconds. And then what are we doing next? Current angle is 0. All right. So here's where we publish the message. So we'll say velocity publisher, which publisher dot publish and let's do t1 equals ROSPy. So we're setting a new time. I'm just copying this code. It's not something I have memorized. All right, angular speed times t1 minus t0. This should do it. Let's go ahead and add the stop. They had a stop here at the bottom. Let's do the same thing just to be safe. And so I already have a stop message created, so we're just going to do this. So let's just try this and see if it works. Let's let that load, and we'll go back to IoT. We need to shrink this just a little bit. We're going to change this data. Oh, I didn't do one thing. So let's do Python listener, nano listener. Yeah, you remember, I did not remember these formulas from school. I remember the first 3 digits of pi, and that's about it. All right, so we want to say, okay, we're going to get a command to the callback. If command equals forward, we'll go forward. But we forgot to add this part. elif command equals spin. Let's do that. And let's try again. So if this works, it should spin, and then what we'll do is go to Alexa, add in a spin intent, and then try it from there. So we're listening on voice drive. Everything looks good so far. Let's just hit forward. I'm gonna go to robot view for you. Let's send forward again just to see, make sure that works. Oh, you can't see the robot. Where's robot cam? There we go. It worked, but I'll do it again so you can see it. Good. All right, so moment of truth number 1. Let's change this to spin. So I'm just going to change this data message to spin. And we'll publish. Kind of center it up a little bit. Which way do we need to go? Here we go. All right. I hit publish, but nothing happened. So let's go and debug. This is the fun part of any live coding. All right, so we did get a spin command, which that's good. Did it actually go to the spin function or method? So let's look for def spin. Def spin. All right, what did we do wrong here? Let's print something here. Print. Depending on you, Twitch audience, to find my code mistakes. All right, so angular speed, that looks good. X, Y, and Z of linear are good. X and Y of angular are good. Oh, we never set the Z, did we? Okay. So let's go look at our code that we're plagiarizing right here. We didn't copy this at all. So that would make some sense. So let's set it right here. Velocity message dot angular dot z equals the absolute value of angular speed. All right, let's try this. So again, the listener is what we need to listen to messages that are being sent to us. We're definitely getting the message. We saw that in spin. All right, so let me go back to the IoT tester. I'm gonna hit publish and you should be able to hear it. I'll switch over to robot cam. There we go. It spun a little bit. There it goes. Little jerky, little herky-jerky, but I'm happy with that. For a live demo, that's good enough. Not enough semicolons. Oh man, do we have a old school developer in the house? Trinity. All right. Great. So we've got that. Let's add a new intent here. So here is the intent. Hopefully, if you're on this channel, you're familiar with Alexa Skills Kit. I'm going to assume you are for now, but if you're not, that's okay. We'll get you to this point, no problem. But we're going to add a new intent. So you see I have a few like hello world. That gives us a little intro, move direction, stop, etc. So let's add a new intent. We'll call this spin intent. And I've already got the code for this, or the code to handle the intent here. So let me show you this. Spin around intent, okay? So all it's doing is listening for spin around intent. And I'll show you what that looks like in just a second, but I needed this name right here. Let's go back. We'll call spin around intent. Create it. Is Z an angle or angular speed? Z is the, for angular, it's the rotation speed. So if you, so imagine Z is the vertical axis and it spins around the vertical axis. Okay, so sample intent, what would someone say to invoke this intent? This would be spin, or spin around, or, I don't know, twist, we'll call it twist, it's fine. All right, spin around intent, and let's save that. Let's build it. Okay. So let me show you this code, what's happening here. So this is my code for the Lambda function. So there's a Lambda function that handles the Alexa Skills Kit payload and then does all this work. I do my Lambda functions in Python, so apologies if you're used to Node. Hopefully you will try the new SDK features out that we're releasing and we've released recently. But here we go, Lambda function. So this is all boilerplate code that you get when you set up the SDK, the IoT SDK. So I've done nothing special here other than copy code, and I will paste this to the GitHub repo too. Let's see. So what happens is, let's look for spin around intent, which is right here. It says, okay, spinning, and it does this, send MQTT instruction. So the pub sub method works with MQTT, that's a protocol, or it works with WebSockets, or it works with HTTP. So I chose MQTT, you can choose any of those. So if we go look at MQTT instructions, all it does is formats the message for me. It adds some brackets around it to make it look like JSON to my ROS instance. And then it publishes to voice drive, just like we did with the AWS IoT test console. We're going to publish through the SDK to that same topic. And again, if you had lots of robots, a fleet of robots, let's say you had drones and you wanted them to spin around or change colors, one push to that topic would affect all the robots. It's really cool, really powerful. So that's all this does. Let's just try it before we test it. Normally I'll go test and try it. Let's try it with a real Alexa. Alexa, open Twitch Robot.
Hi, I'm your friendly robot. You can give me commands like move forward, move backwards, or spin around.
Spin around.
Okay, spinning.
So now it's kind of angled towards, let's do it this way. Let's see if we can drive it off the cliff. Alexa, open Twitch Robot.
Hi, I'm your friendly robot. You can give me commands like move forward, move backwards, or spin around.
Forward.
Okay, moving forward.
Sorry, that wasn't really in the frame. Okay, so that works.
Hi, I'm your friendly robot.
Thank you, friendly robot.
You can give me commands like move forward, move backwards, or spin around.
What I'll do is keep Twitch Robot going. So I think it'd be really cool to have Twitch Robot tell me when there was a new message pop up, when we had a new subscriber on Amazon Alexa. So we'll keep building on Twitch Robot. I'll create a GitHub account called, let's do it now. That way you can see it and have it. Let's go, just open a new shell. All right, let's just create one. I wonder if I can create, well, I'm going to create one on my laptop so that you don't see the credentials really quickly, and then I'll share that URL with you so you can have it. So let me create this. It'll take just a second. We're going to call it Twitch Robot, and I'll post all the code you need to get started. Now, if you don't have, this is the important part too, if you don't have a create, so this is relatively, we're going to look at this iRobot create, relatively inexpensive when you think about robots. $199. If you don't want to do that, there are some other options too. So there are good simulators that have the create built into it already. So you can get the simulator, and I have that on my GitHub as well. So when you're on the GitHub page, there's a simulator I have called ROS Desktop Gazebo. ROS Gazebo Desktop. You can take this, I have all the instructions you need to set it up. You can take this and make sure that I'm showing you my screen. You can take this, set it up, and then have everything you need to simulate this create robot without having to go buy it. And that's pretty important. You can also do it with AWS RoboMaker. So we'll have the RoboMaker team on a little bit later in the year too. They have all of this huge simulation environment, great way to test your robots. Takes a lot of the burden off of building things and trying to get things work together. I just have a few features on this. So I have the Gazebo, which is the simulator. I don't have any kind of visualizers like RViz. There's an RViz and RQT that help you visualize a robot and get telemetry data from it. RoboMaker has all of that built in. So I'll have that team on later too to show you how to do everything in that simulated environment that you can try. But if you want to get started quickly, you can do that. The other thing you could do is just build your own robot. So I think it's called GoPyGo. Let's check this one out. GoPyGo Robot. This is another way to do it. So there are some relatively inexpensive. This is actually a good one here, $69. And it looks like, I haven't tried this one, but I think it's probably a Raspberry Pi. You can add one. Really all you need are servos and a wheel and a Raspberry Pi. You've got a little robot. So you can do the same thing with that. You don't need the create, you just need, you can use the exact same code and use the exact same topics if you want to. Okay, so the GitHub repo you need is, let's go here, Twitch Robot. So there's no code there yet, but after this, we'll get all that code up there for you. Okay, one more thing I wanted to show you on this. So if you decide to get into it and do, I see there's a comment about kindly share a list of entry-level and affordable robots. Yes, I agree. We'll get you more of a, I don't know, a recommended list. Here's what I would do though. This is a great way to get into it. This is a Raspberry Pi. Raspberry Pi you get for about 35 bucks. There's a new one with 4 gigs of RAM that you should look at, and it's around 55, but it's totally worth it because you have RAM and it's very fast. It's like a small desktop computer that existed maybe in 2011 or 12. What I would get extra though is this little battery pack right here. So this battery pack is a lithium-ion battery. It lasts, it says, for about 8 hours. And we've been doing the show, and I still have at least 75% battery left. So there are 4 red dots usually when it's fully charged. You can see 3 right now. Get that lithium-ion battery. That way you don't have to have your Raspberry Pi plugged into the wall, and then you can't really do much with your robots. They won't go too far. And I just got a little simple Velcro strip here. Got a little simple case. This whole setup right here that you're looking at, just the Raspberry Pi and the battery pack, was probably $50. And like I said, all you would need after that are maybe some servos and wheels if you want to make things move around. Okay. So now let me go and see what questions we have. Let me start back at the top real quick just to make sure we didn't miss any. Let's see. Affordable robots we've covered. Okay, good. So looks like the Roomba 560 has this weird connector. So is that weird connector maybe a serial cable that you can use as well? The new Raspberry Pi. Let me show you the new Raspberry Pi. Raspberry Pi 4. And look, if you're going to go with it, it's out of stock in most places. If you're going to go with it, you can get the cheaper one for $35. It will do great. I promise it will do great. But you want to make it more future-proof, then just bring a little bit extra if you can and get that $55 one. So we'll put this paste here, or link here. But that 4 gigs will really help you. Make sure that works. There we go. So that's that. But again, you don't need it. So if you want to go with the 1 gig, that will work fine. The one I'm showing you now is an old Raspberry Pi 2. So it actually works just fine on a 2. If you want to pick up one of those, you can probably find those on eBay really cheap, maybe 15 or 20 bucks. The one I haven't tried yet, I have the Raspberry Pi Zero. I think it's the Zero or the Nano, and I haven't tried that yet. All right, so good. And then again, look at the GitHub repo for the ROS Gazebo desktop. Let me show you what Gazebo looks like. See if I wonder if I can spin that up real quick. I think it would take too long. So Gazebo again is a simulator, and let's see if we can find a decent picture. It basically launches a virtual world, and in that virtual world, then you can spawn robots. So one of the robots you can spawn is the Create. So in my GitHub repo, that is the robot that I include with it that you can spawn. Let me show you real quick. I actually may have taken a picture of it. I think I did. Let's go to repositories, ROS Gazebo desktop. Okay, so here's how it started. Here we go. So this is what it looks like. So you will spawn. You can just do ROS Gazebo run, do this file, copy and paste that file. Here is where you specify the model. So the model is the Create. And again, that's the robot that we've been working with today. That will add it here. You can add different worlds. So there's just this empty world, this empty virtual world. There are some really complex worlds that have lots of parts or pieces to them, models. So things like park benches or coffee shops, or I haven't seen Rubble World. I'm assuming it's like the Martian landscape. And just like we did with that code I showed you earlier, you can make the robot move around. So in this repo, if you clone it, you'll be able to do a lot. In fact, all of what I did just by having this repo. So try that first if you want to get started quickly without buying a robot. Okay. Any more questions that we have? Looks like Trinity wants me to vacuum his house. Yeah, that's the beauty of this, right? I can go back and throw this in Trinity's house. We can at least make it spin. I don't know about vacuum yet. It's going to take some time, won't it? Some talk about, see, look, the cool thing about this channel is we can kind of go off topic, and I'm going to go off topic right now and talk about Ready Player One by Will Wheaton. That is a really good audiobook. So if you haven't had a chance to read that, read it. It might inspire you to listen to it, I should say. It might inspire you to do a cool robot. All right, let's go back to the chalkboard one more time and make sure you understand PubSub, or the three methods. Okay, so this is what we'll do over the next few weeks. So next week I'm going to go into Bluetooth, the Bluetooth communication with a device. So I'll use the Raspberry Pi and pair it with my Alexa. or Echo device, and then have my Echo device send commands to the Raspberry Pi to do something. I think right now maybe I'll have it spin a motor just so we can see what that looks like. Maybe we'll turn on a light. Maybe we'll cycle through some colors. While we're talking about that, let me show you so you want to get started on that a little early. Just do a quick search for Alexa Gadgets Toolkit. So this Gadgets Toolkit will get you started. And it has all sorts of sample applications that you can start getting into. So we'll go into Bluetooth over the next 2 weeks. So I'll have some members of that team come join us. All right, and then the third way we'll get to a few weeks from now, maybe 4 weeks from now, will be the direct communication. So if you want to actually build Alexa into a device and not have an Echo device sitting anywhere, you just have Alexa on the device itself with microphone, with speech recognition, with wake word detection, with audio processing. Okay, let's see. Sir, there was a question about addressing messages to a particular device. Let's see what we have here. Is there a way to specify a particular device, not just to send to a customer? So, yes. So what you can do, let me show you this. So if you have a particular device, right now I'm blasting it to everything listening to voice drive. You can just namespace these. So I could have create 1 and create 1,000. So I just namespace these, and then my robots listen to their own topic. So this, if you notice, let's go here. Let's make sure I'm not lying to you. So we're still listening, right? Still listening. The last command was moving. Let's send spin to create 1 voice drive and see what happens. Let's put the slash here. Publish. Whoops, I don't want that. Okay, good. So it's still moving was the last one. We're still good. So that's how you would send to specific devices. Does that answer your question? Any entry-level and affordable humanoid bot? Those are tricky. So you can definitely get humanoid bots, but they're like, if you want a cool one, well, I guess it all depends on the definition of affordable. There's a decent one, I guess, for $523. I haven't seen that one yet, so I don't know much about that one. I want PPPER. I don't know of any. I mean, there's the iBo and there are things like that, but I haven't seen a good affordable humanoid robot. But I would love for you to make that. That'd be really cool. I think you just need you start off pretty simple, maybe 6 servos, like 2 shoulders and hips and then knees maybe, and start from there. But servos are really relatively inexpensive if you want to do it yourself. And then each servo can have its own topic. So, we were sending things to voice/drive. It might be shoulder. That's all it would be. And then you send a rotation to shoulder, a rotation to hip. Adafruit has really good components. So if you go to Adafruit and look for components like servos. Yeah, so that's a pan tilt one. There's a micro one. I have a few of these. $6 for a couple of those. You can make a small miniature humanoid. It'll take some more thought and planning to build a larger one. List the items for a humanoid robot. I'm not familiar enough with building a humanoid robot. So one other thing we're planning on doing here that I don't think I mentioned yet is having some professors on from different universities that I've worked with before that are really, really good. They're the experts in this field, and they're really good about building things. One in particular has worked with a lot of humanoid robots. So I'll reach out to him. He's already expressed some interest in coming on. We'll try to plan that episode out. I think that would be really cool to see how they build humanoid robots. Another one I have in mind that was willing to come on is, or I hope he is still, he makes nanobots. So I think that'd be really neat to see too. So how we can go from big humanoid bots to nanobots. But that does bring up a good point. Like the point of this show should be for us to take the journey together and to learn together. So if you have ideas like that, I'd love to plan episodes around them. So you can reach me on JBNunn at Twitter. Follow me there. Reach me there. Send messages to that or Alexa Devs on Twitter. But we'd love to hear your ideas for the show. So pub sub topic would be for all customers, not specific customer. I do not see how to specify my particular device, say thermostat in my kitchen. So you need to register your specific device for the particular customer. Let me think about that. Well, if you had a thermostat in your kitchen, couldn't you just say thermostat /1 and then adjust or temperature and send the temperature that you want to get to? I think I see what you're saying too for all. Well, maybe I need to understand what you mean by customers. Are you saying customers in the traditional sense of like a SaaS product or a product where you have multiple devices with multiple customers? Or in this case, are customers just devices? One instance. Okay. What I would do is just I would just namespace it. So I lost my IoT window. Let's go back here. I would just namespace that. So if you have a thermostat in the kitchen, it's eventually going to load. Then just namespace it with slash, maybe even slash kitchen slash temperature or slash thermostat slash temperature. So let's go to test. I'll just show you some examples real quick. Here, I'll type it here too. So let's do slash thermostat slash temperature. Let's just say thermostat kitchen, and then thermostat. Maybe you have a dining room. Let's say dining temperature. Oh, I'm typing this slash is throwing off Twitch. Thermostat kitchen temperature. So in this case, only the thermostat should subscribe in the pub sub model. Yeah. I'm sorry, this page isn't loaded. Here we go. So yeah, your thermostats could subscribe to your thermostat would subscribe to the right topic. So you're publishing to a specific topic that your device is listening to. If that doesn't answer your question, though, I definitely want to figure that out with you. So DM me on Twitter at JBNunn or just message me on Twitter. We'll handle it from there. I'll share my email address with you and we'll go from there. Okay, did I miss any more questions? Startup, did you get a good enough answer for now on humanoid robots? I'm going to definitely follow up with me on that one too on Twitter, and I'll let you know. We'll do some good marketing when we get the professors on that want to talk about their humanoid robots, and I think that'll be a good episode for you. Okay, so it looks like we have all the questions. I'll give another minute or two for you to post them if you have them. If not, let me just tell you what's coming up over the next couple of weeks again. So next week, I'm going to do a lot of live coding. It'll probably be me making a lot of mistakes trying to live code with the Alexa Gadgets toolkit. And then we will have the experts from that team on the following week on September the 7th. And is it the 7th or the 6th? It's the Friday, the first Friday of September. So we'll have them on with us. And then they are the experts. They've been building a lot of cool sample demos that we want to show. So we'll show those. We also have a couple of surprises in store. So all I'll say is get your robot skills sharpened. If you like winning prizes, then get them sharpened. That's all I'll say. I hope that's a good enough hint without giving too much away. All right, so it doesn't look like there's any more questions. I will be on Twitter. You can catch me on Twitch again at JBNunn. Next week I'll be streaming Monday or Tuesday on my own channel, just doing some prep work and some behind-the-scenes stuff. I might even do a stream about creating the GitHub repo for you, but I'll post all of that code to the GitHub repo. All right. Thanks everyone for joining. I hope you had a good time. I hope you learned a lot, and I hope you're excited to go build, and I'll see you next time.